Hi everybody, this is Miss Thompson and we are going to fill in some notes about arithmetic sequences. Please bear with me, this is my first video that I've ever created and the couple of times that I've tried it already have been a complete disaster. So laugh with me if something funny happens and then let's move on. So what is a sequence? A sequence is a list of numbers that changes in the same way repeatedly. Okay, so an arithmetic sequence is a special kind of sequence that changes repeatedly through addition or subtraction over and over. In the next couple of days, you're going to also learn about geometric sequences, which change by multiplying or dividing. So the amount that an arithmetic sequence grows or shrinks is called the common difference. Wow, the writing on this video is terrible. Okay, also known as slope, which you guys should be familiar with at this point, or the constant rate of change. That's going to be really important later. So if it is increasing, the constant difference will be positive because it is adding. And if it is decreasing, the constant difference will be negative because it is subtracting. Graphs of arithmetic sequences will always be linear. And in order to draw the graphs, a negative common difference and a positive common difference. Negative is going to go like this. Sorry about that. Like this. Positive is going to go like this, just like slope. You're also going to be asked to make a table for sequences. Trying to pick colors here. Let's use red. Okay, so the term represents the x value, and the number represents the y value. You'll see what I mean in just a minute. So note, when given a sequence in a list, the first number given is term 1, not term 0. That's very important when writing the explicit function. You'll see that in just a little bit. The explicit function for an arithmetic sequence basically looks just like y equals mx plus b, only we use function notation. So instead of y equals mx plus b, we have f of n, typically we use n for sequences, equals mn plus b. Very similar. This right here is going to be your common difference. And this right here is going to be your term 0. Remember I said that the 0 versus the 1 was going to be really important. That's where it's going to be important right there. Then we also have what's called the recursive function. And the recursive function looks like this. F of n equals f of n minus 1. And then you're going to take that and you're going to add a plus or a minus, depending on if you're increasing or decreasing, and then your common difference. So the common difference that you see right here goes right here. Then we also need to include a comma, and then we say f of 0 equals, and then fill in the blank. That's going to come from right here. The term 0 goes right there. So basically what this says in words, if I can fit it on the screen here, is next, the next term in the sequence is equal to the previous and then we have the plus or minus something. And this f of 0 right here means starting with. Sorry for all the chicken scratch, guys. Okay, so multiple representations. You will be given information for these sequences in a variety of ways throughout this unit. You will be asked to complete the remaining representations. So in this case, we're given a tile pattern, which is pretty common because it's hard for students to create tile patterns on their own. So if you notice, you are given the stage 1, stage 2, stage 3. This is really term 1, term 2, and term 3. So over here, you're going to fill in stage 4, which is term 4, stage 0, which is term 0. Remember, the 0 and the 1 get confused often, and it's important to know which one is which. So first question says to draw the figure for stage 0 and stage 4. So first thing we need to do is figure out how this is growing. So if I kind of put an X in each of these boxes, and an X in each of these boxes, and this is just how I visually see it. Others see it differently. Then what I can see is that these 3 boxes right here are new. Then these 3 boxes are new. So what I see is that I'm adding 3 boxes on the bottom each time. So in order to draw your stage 0, I need to take away 3 boxes. So it's just going to be 1 box, because I'm going to take away these 3. Then, to draw my stage 4, I need to add 3 more boxes. So this might be a challenge with my computer technical issues here, but we'll give it a go. So there is my stage 3 currently. 3 rows, 1, 2, 3, that have 3 each in them, plus the 1 right there on the tab. Then I'm going to add another row. So this is the new row. So stage 4 has 3, 6, 9, 12, 13 tiles in it. Going back to stage 0, we have 1 tile. Okay, so my sequence, for writing out my sequence, we always start with our first term. So we're going to start with this and list it right here. So this has 4 tiles in it. So I'm going to put a 4 right there. Stage 2 has 3, 6, 7 tiles. So I put a 7 next. Stage 3 has 10 tiles. So I put a 10 next. And we already saw that stage 4 has 13. So there's some extra blanks here, and typically you're going to be given some extra blanks that you'll have to fill in. So if you notice, from one term to the next, we are adding 3. We also saw that in the tile pattern, in the fact that 3 blocks were being added at the bottom. So if I continue to add 3, I'm going to get 16 here, 19 here, and 22 here if I'm doing my math correctly. Now we need to fill in tables. You're going to see horizontal tables and you're going to see some vertical tables here. So since the term numbers are not given to us here, we can fill in our own. Sometimes you'll be given specific term numbers. So I'm going to start with 0 and then 1, 2, 3, 4. Same thing with the vertical table, 0, 1, 2, 3, and 4. So then if we go back to our sequence, we have 4, 7, 10, 13, etc. So I'm going to pull those in. 4. Oops, that was actually wrong. Hold on, where's the eraser? So we have a 4 was term 1. So that's my first in my list. I almost made the same mistake that most students make. So I had 1 tile or 1 square in figure 0. And then here's my 7, my 10, and my 13. So same thing with the vertical, 1, 4, 7, 10, and 13. You might see it either way. Okay, so for graphing, this might be tricky because I'm having a hard time controlling this, the drawing on here. But basically, this is going to be your term, just like we were graphing from the table. So this is going to be 0, and then we had 1, 2, 3, and 4. And if you remember, that was 0, 1, and then we had 1, 4, and then we had 2, 7, 3, 10, and 4 was 13, if I remember correctly. Let's just check. Yep. So then going up the side here, we're going to have our value, which is the number of tiles. So we're going to go by ones here. So this right here is going to be 5, and 10, and 15, and 20 up here at the top. Now let's just plot points. So term 0 was a 1. Let's change colors here. Plot a point right there. Term 1 had 4, so we're going to make a point right there. You get the idea. Term 2 had 7, so let's make a point right there. Term 3 had 10, right here. And then term 4 had 13, so that would be right there. So if we were to connect those, we would have a linear function. What you're going to learn about in the next couple of days is that sequences, especially if there's tile patterns, are actually what's called a discrete function, in that you actually can't connect them with a line, but we'll go into more detail of that in the next couple of days. Okay, so the common difference, in this case, we were adding 3 over and over again. So we're going to write down that that is a plus 3. Now, increasing or decreasing, that should be obvious, I hope, in that because it's a plus, it is increasing. So where can you find this in the tile pattern? That was the plus 3 blocks. Okay. And then in the sequence, which was the list of values that went like this, we also had where we could go like this, plus 3, plus 3. And then in the tables, I'm going to actually take you back to the tables to show you that one, because it's really important that you be able to do that in the table. So let's choose red here. So we want to say plus 3, plus 3, plus 3, and it's adding 3 over and over because here we have a plus 1, plus 1, plus 1, etc. So here's my 3, here's my 3, and my 3, and then my 1, and 1, etc. Now, in the graph, remember that we said that the common difference was also known as the slope. So since this is slope, we should be able to see the rise over the run on the graph. So let's go back to the graph. And right here we have a 3 and then 1. I know that right there it looks like we went over to the right 5 boxes, but remember this right here is a jump of just 1. Okay, so last little bit is finding unknown values. Really the only way and by far the easiest way to find this is to use the explicit. Okay, sorry about that. The phone rang, unfortunately. So for finding unknown values, find f of 10. The best and actually only way to find some of these things is to use the explicit function, explicit. And what I just realized as I was getting ready to use the explicit function is that we didn't actually write the explicit or the recursive function for that. So we're gonna sort of add a slide here, and so somewhere on your paper what I want you to do is create a space for what I'm about to show you. So the explicit function, remember, is the one that goes f of n equals, and we have that mn plus b, okay? So the m right here is my common difference of plus 3 because we were adding 3 tiles over and over. And the b right here is my term 0, which is where we had only 1 block. Notice that's not the term 1 where we had 4 blocks to start with. That's term 0. We had to go backwards to get that. So now to write our recursive, we had that f of n, which means the next term, is equal to f of n minus 1, which is the next, or the previous term, excuse me, plus or minus something is what our notes say. So in this case, because we have a common difference of 3, we have a plus 3. And then we have to give it a starting point, so we're going to say that we started with 1 square. Let's put a 1 right there. You can also, as a separate example, you could have put in here that my first term was 4. This one doesn't have to be an f of 0. This one you have to use the term 0. Okay? Here, down here for the recursive, you have a choice. So we're going to use this explicit function to answer the questions that were on the previous slide at the bottom of your note sheet. So we had an explicit function of f of n equals 3n plus 1. This is an n value. So I'm going to take my 3, plug in, plus 1, and I'm going to replace that with a 10. So when I do that, 3 times 10 plus 1 is 31. So this is going to be the number of tiles in the 10th figure. Okay, so now the next one is a little bit different. Notice it's even worded differently. So this says to find n. So what we don't know is this n right here. What we do know is that f of n equals 46. That's this. So I'm going to plug in my 46 over here, and then I have equals my 3n plus 1. So this is basically saying which figure number has 46 tiles. So follow your usual solving steps to figure out what x is, only in this case it's an n, so minus 1. I get 45 equals 3n, because this canceled. And then I'm going to divide by 3, and I have n equals 15. So the 15th term would have 46 tiles in it. Double check, make sure that that's everything. It looks like we're all set. Sorry for the 20-minute long video. I think once we get technical difficulties figured out, it'll go much faster. See you guys tomorrow.